Hi, my name's Gabe. For this problem, we're asked to find the equation of a line which is tangent to the function f of x equals negative 1/4 x squared, which is also parallel to the line x plus y equals 0. So let's begin by finding the slope of the line. So we know the line that we're looking for should be parallel to the line x plus y equals 0. So let's start there. So we can rewrite the equation of this line to be in slope-intercept form by subtracting x from both sides of the equation. So we have y is equal to negative x. Now if we're looking for a line which is parallel to the line y equals negative x, we know that the slope should be negative 1. Now to find the equation of a line when we know the slope, we have to find a point on the line. And since we're looking for a line that's tangent to this function, we want to go ahead and find a point at which the derivative, or the slope, of the graph of this function is equal to negative 1. So let's go ahead and take the derivative of our function. So recall f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So now we can substitute x plus h and x into this equation to find our derivative. So substituting x plus h in for everywhere where there's an x here, we'll have the limit as h goes to 0 of negative 1/4 times x plus h, this quantity squared. And we'll be subtracting our original function, so minus negative 1/4 x squared. And this is all being divided by h. Now here, we can simplify the expression that we're taking the limit of. So this leaves us with the limit as h approaches 0 of negative 1/4 times x squared plus 2xh plus h squared. And here we're subtracting a negative 1/4 x squared, so this is going to be the same as adding a 1/4 x squared. And we're dividing all of this by h. So now we can go ahead and distribute this negative 1/4 to everything inside the parentheses, which leaves us with the limit as h approaches 0 of negative 1/4 x squared minus 1/2 xh minus 1/4 h squared plus 1/4 x squared, and this is all divided by h. So here we see we have a negative 1/4 x squared and we have a 1/4 x squared, so these two terms will cancel. And let's also note that in each of these middle two terms, there's a factor of h. So we can go ahead and factor out an h from each of these terms. So this leaves us with the limit as h approaches 0. We're factoring out an h. So we're left with negative 1/2 x minus 1/4 h. And this is all divided by h. Since there's a factor of h in the numerator and denominator, these will cancel. And we have the limit as h approaches 0 of negative 1/2 x minus 1/4 h. And at this stage, we can evaluate the limit by substituting 0 in for h. And this leaves us with negative 1/2 x minus 0, so just negative 1/2 x. So this right here is the slope of our graph of our function at any point x. And we want to find the point at which the slope of the graph of our function is -1. So the equation that we want to solve is the equation -1/2 x equals -1. Now we can multiply both sides of this equation by -2, and we have an x value of x equals 2. Now to find the point that our tangent line passes through, we can substitute this back into our original function. So f of 2 is equal to -1/4 times 2 squared, which is -1/4 times 4, or -1. So the point at which our tangent line passes is the point 2, -1. So, now that we know the slope of our tangent line and the point that our tangent line passes through, we can go ahead and write down the equation of our tangent line using the point-slope form of a line. So we have y minus y1, which is minus -1, which is going to be a +1, is equal to m, our slope, which we found to be -1, times x minus x1, which is 2. So here we can subtract 1 from both sides of the equation and distribute the -1 to both x and -2, leaving us with the equation y is equal to -x plus 2 minus 1. And here we can simplify, leaving us with y equals -x plus 1. So what this is this is the equation of a line which is tangent to the graph of this function and parallel to this line. Thank you.